So, what are vector embeddings? Understanding how AI transforms complex data into meaningful numerical representations that power modern search, recommendations, and intelligent systems. Vector embeddings turn things like words, pictures, sounds, or videos into lists of numbers that capture meaning. With those number lists, AI can measure how alike two items are and group or retrieve them accordingly. Common kinds of embeddings: text embeddings encode the meaning of sentences, phrases, and documents, great for chat systems, semantic search, document lookup, image embeddings from the name, audio embeddings from the name. Easy to understand. And these three types of embeddings are things that our everyday apps that we use on our phones use to store data. Like Spotify uses probably audio embeddings to store the customer profile or the songs that a person listens to so that they can recommend new songs to them. These are ways that big apps use these, and these are very effective as well. Picking an embedding size. Once you're building inside of N8N and using OpenAI embedding models, you're going to have two options: text embedding 3 small, text embedding 3 large. The 3 small is faster, cheaper, and good for broad everyday tasks. The large, higher detail and accuracy for tougher, nuanced use cases, bigger indexed, more precise retrieval. So when you want to choose, the 3 small is useful and we use it for most of the cases. The 3 large is going to capture more meaning, but it's going to cost you more. And I'm going to explain what I mean by that in the next few slides. Bottom line, embeddings give AI a shared numeric language for content. They power semantic search, recommendations, and matching, making systems smarter at finding and comparing what matters. As we mentioned in the vector database and RAG video, embeddings are the things that turn texts into vectors, and those vectors hold meaning for the text. So, this is how AI models can understand text and search for information and data. So they are very important. They give AI a shared numeric language because AI now search for the meaning through the numeric language, which is the vectors inside the vector database. Vector dimensions. A vector is a row of numbers that describes something. The length of that row, how many numbers it has, is called its dimensionality. Dimensionality affects how well AI can represent meaning, how fast it runs, and how accurate its results are. What a dimension really is: think of each number in a vector as one attribute or signal. Example, different domain. A game character might be described by speed, stamina, and magic. That's three dimensions, one number per attribute. So you have number one, two, and three. Three dimensions: speed, stamina, and magic. Let's say you want to describe your friend. You're going to describe their height, you're going to describe their size, you're going to describe their hair color, eye color, their style, so on. These are 5 or 6 different attributes, and this means the vector is going to be made up of 6 numbers. This is its dimensionality. From easy to abstract, let's go back to middle school where we used to learn space. So, one dimension is one number, it is a point on a line. Two dimensions are two numbers on the vector, which is a point on a flat area. Three dimensions, three numbers, lives in space. Four dimensions and above is something that we cannot picture, but remember the example I gave you. One dimension is one number on the vector, which means or represents one attribute. So the more dimensions you have, the longer the vector row is going to be, and the more meaning it's going to hold, richer, more dense meaning. Why the number of dimensions matters. Number one, detail versus simplicity. More dimensions means more room to encode subtle differences, good for meaning. Fewer dimensions means faster and simpler, good for latency and cost. Two, real content is rich. Text, pictures, clicks, and behaviors are often encoded with hundreds or thousands of dimensions. So, since real content like pictures, videos, images, long articles have a lot of meaning for us to represent in vectors, longer vectors are going to be able to capture most of that meaning. So, the longer the vectors, the better to capture more meaning. Number three, too low versus too high. Too few, you lose important nuance. Too many, slower search, noisier models, harder to reason about. Four, the curse part: in very high dimensions, points spread out. Distances get less helpful, models may chase noise instead of signal. Let me share with you some practical applications and guidance. So, vector database real life example: music apps or Netflix recommend next song or movie by analyzing your habits and interests. And this is where I gave the example of Spotify. It literally uses vector databases or similar structures and databases to be able to recommend next songs. Quick recap. One dimension is one feature in a vector. More dimensions capture richer patterns but can slow things down and add noise. Aim for a balance. Enough detail for quality, not so much that you lose speed and clarity. These were vector embeddings and vector dimensions. Hope you understood these somewhat complex concepts. With that being said, thank you for watching this video and see you on the next one.